Okay. Now please pay attention. Today we are going to look at different scenario. Such that the drawing is done with replacement. When Johnny, okay, for example, Johnny, draw one ball from the bag and and put another ball with the same color back into the bag, okay? So it is the what number? Okay, this is the first case, first scenario. All right. Second scenario, number 2, on the left, and number 3. Now it is number 4. Now suppose that Johnny suppose that then he draw 5 balls. With replacement. When he get one ball from the bag, he put the same ball back. Okay, to same ball back into the bag. Okay, so the drawing is done with replacement. So for example, how many balls are there in the bag? How many balls? 4 in the bag. Um, four, 4 red and 3 black. Okay. For example, you don't draw this. All right. When Johnny get this one, okay, get this one. So this one is drawn out of the bag, right? And someone put a ball back into the bag. All right. Suppose that this is the replaced. With replacement. All right. When a ball is drawn, a ball with the same color is put it back. Put it back into the bag. Okay? Okay. So 5 balls. And let be the number of red balls that Johnny gets. Then, for example, probability x equal 3. Okay, equal 3 means he got 3 red and 2 black balls. All right? So, what is the probability that he get 3 red balls? To get 3 red balls, when he draws the first ball, the probability of getting a red is 4/7. 4/7, 4/7, 3/7, 3/7. All right? Okay. So that's the probability, right? That's the probability of getting 3 red balls and 2 black balls, right? But the 3 red balls comes were selected at the first 3 drawings. And 2 black. At the last 2 drawing. But, hey, but this is also but this is also 3 red balls and 2 black balls. 3 red and 2 black. So is this. Right? And so is this. The 3 red balls appear at the last 3 drawing. All the same. The probability are the same. There are 10 possible. Okay? 3 balls were selected at the first 3. 3 red balls were selected at the first, the second, and the fourth. The third, the fourth, and the fifth. They are all the same probability. How many? 10. Okay? So it is 10 times 4/7. Three times, and the two black, okay, 10. But as you know, that I don't like the expression, the mathematical formula, the expression is correct, but that is what I like. That's not the expression that I prefer, although it is correct. It is correct, but not what I prefer. Okay. So what is it? What I prefer is this expression. 5 choose 3. All right. 5 choose 3. 4/7 raised to the power 3, and 3/7 raised to the power 2. All right. But I don't like power 2. I like 5 minus 3. All right. And so is this. Where 10 equal C5 choose 3. Total number of three success out of 5 trial. You can succeed. You can succeed here, here, and here, or here and here and here, or here and here and here. 10 possibility. All right, it's 10 possibility, and and so 10 is 5 choose 3. You choose 3 places from 5. You choose 3 places from 5. Okay, to place 3 success, to make 3 success. Okay, so let us generalize. Let us generalize. To generalize. So probability x equal 3. It is C5 choose 3. 4/7 to the power 3. 1 minus 4/7. 5 minus 3. Okay, to generalize. Probability x equal x, little x. Five minus x, and x can be 0. You got no red ball, okay? Or you got one. He got 1 ball, or he got 2, he got 3, he got 4, he got 5. Okay. To generalize further. Furthermore, all the way up to n. All right. In this case, we call binomial MP, random variable. All right. And such experiment is called binomial. Such distribution, sorry, is called binomial distribution. All right. Yep. What? C5x? 5 choose x. So what is your question? Five choose x. It means there are 5 places, right? 1, 2, 3, 4, 5, right? And you choose 3 of them to place success and 2 of them to place failure, right? So how many ways you can choose 3 out of 5? You can choose 3 success here, right? Or 3 success here, or 3 success here, or 3 success here, right? No. Or 3 here, right? Any other? Um, um, I think no more. Here, right? And here. Yep. You can choose such 3, such 3, such 3, such 3, such 3, such 3. And and this one. Yep, and this one. Right? Any other? Yes. This one and this one. Oh no. And this one. Right? And this one. And also this one. So all these 10 cases are 2 red balls and 3 red balls and 2 black balls. Okay? For example, 3 red balls comes out at the first, third, fifth trial, and the 2 black comes out at the second and the fourth. So 10. They are all 3 red and 2 black. Okay? All right? Understand? So 10 is the number of times 3 items drawn from the 5. Okay? That's what we discussed the last week, previous week. Any question? Okay. If you don't have any question, then I'm going further. Note that here in this example, Johnny did 5 independent Bernoulli trial. Okay, so what is Bernoulli trial here? Bernoulli trial is here. Yep. Here, Bernoulli trial. Either Bernoulli trial is an experiment. Okay, that is just done just once, okay, once. Either success or failure, and the outcome and the experiment has only two possible outcomes, which are either success or failure. If Johnny gets a red ball, we call a success. Otherwise, he get a black ball, and we call the outcome is a failure. So so the Bernoulli trial is done just once, but here Johnny, how many times? 5 times of Bernoulli trial. Okay, so let at the J drawing. Okay, and here we call it success. All right, for J from 1, 2, 3, 4, 5. All right, and then is the binomial 5, 4 over 7 random variable. Okay, sum of 5 Bernoulli random variables. Okay, um, and that's what happened. Hi. Okay, and It is a straightforward, not complex, straightforward. That's n times p and the variance of x, the variance of I1 plus I2 plus IN and P1 minus P. All right? Single Bernoulli trial has expectation P, then when you sum them up, I1 to IN, then the expectation will be M times P, where and the X is the binomial. It is very straightforward to generalize the results. This is what we learned last week or last week, all right? Okay, and this is what we learned the other week. But no, sorry. This is what we learned the other week. Okay, now each one has this expectation and this variance. So the expectation of n such Bernoulli trial is n times p. The variance of n such Bernoulli trial, Bernoulli random variable, is n times the variance of a single one. Okay? So in the final exam, you will see the question. Bernoulli. Bernoulli is a French mathematician. Okay? And if you see this question, the answer is true. Yes. Right? Any question? And what number? Number 4. Now it is number 5. Geometric distribution. A new random variable, but the same bag, same draw. All right? Johnny drew a ball from the same bag. 7 balls in the bag. 4 of them are red and 3 of them are black. Consider again the bag with 4 red and 3 black. Okay. And let us consider an experiment. Okay, Johnny draws one ball from the bag. If it is black ball, if he gets a black ball, okay, uh, another black ball is put back into the bag, all right, and someone else put the same black ball back into the bag and let Johnny draw again. If he draws again a black ball, okay, put another black ball back into the bag again and try again until he get the first red ball. Once he gets the first once he gets the first red ball, the experiment just stop immediately. Okay, at once, stop at once. Okay, and such an experiment is called a geometric experiment. Okay, the experiment is done like failure. Hey, success. Okay, stop. The experiment stop. Okay, we will back to the experiment later. 10-minute break. Any question with your examination last night? You are doing great. What? this experiment look like this. Hey, failure, 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 success. Okay, experiment stop. Not do not draw anymore. Or failure, 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 success, and then stop. Here, now here x equal 4. You need 4 experiment to get the first success. Johnny has to draw for 4 times to get the first red ball, and here x equal 3 because he draw 3 times to get the first red ball. Or here x equal 1. Or here failure, failure, black ball, black ball, black ball, black ball, black ball, black ball, black, 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 failure, 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 success. And here x equal 8. Okay. So such a random variable is called geometric random variable. Geometric. Okay. Geometry. Okay. Then probability x equal 5. It means that the first four draw are all black balls. 3/7, 3/7, 3/7, 3/7, and lastly, he make it at the 5th draw, 4/7. But I don't. This correct. This expression is correct, but not what I prefer. I want it to be 1 minus 4/7. Okay. How many times? 5 minus 1 times. And 4/7. All right. Okay. Okay. So to generalize, what if the x is a any general number? Then the formula would be x minus 1. And lastly, he make it a success. Okay. And what is the possible value of x? Hey, Johnny has to draw at least once to get the first red ball, right? So x starts from 1, all right? 2, 3, all the way to infinity. Then maybe he never gets a red ball. He's so so bad luck, so unfortunate. He never make it. Um, you know, um, in Taiwan, when you graduate and you went to the job market and work for a few years, and your parent will say, "Hey, you are getting old. You should have a family." Can I arrange you a blind date? 相亲呢? You know, blind date to make friends. Okay, boyfriend to look for a possible candidate of boyfriend or girlfriend or even candidate of fiance. So you have to attend a blind date arranged by your friend or your parent. Okay, suppose that Johnny he agreed to attend the blind date arranged by his parent. So the first time, oh, it's a failure. They don't they are not fond of each other, Johnny and the girl. Fail again. Okay. Hey, the fourth blind date, they like each other. Okay, and they became a boyfriend and a girlfriend. Became a good couple. So success. And then the blind date will they will no more blind date because they succeed. The Johnny succeeds, right? So the experiments stop. Okay, and when I graduate from school for 3 years, I attend a joint examination. I joined the joint examination. If I pass it, I can work in the government. Okay, that's called public servant joint exam nationwide. I passed it. And I worked in the government for 6 months to get a license. Certificate that promised me I can use it to apply for a job in the government. Okay, that's 30 years ago. 30 years ago, when I was very young, right? And my colleague, there are one. I am the one who make the success at the first trial. I just take the exam. I just took the exam once and I passed it. Then I don't have to take the exam again because I'm a licensed public servant. Okay, and my friend, my colleague, fail, and succeeded in the third year. Some of them fail. Another colleague fail, succeed. Okay. Is there anyone take eight exam to pass the to be a public servant? Yes, one of my colleague. Not so many. Maybe 6 or 7 times. It takes him 7 years to get the opportunity to work in the government. So when you make it, then you don't have to do the experiment again. Okay, you know the spirit of the geometric experiment. You know the spirit. Yes, once you succeed, then you don't have to do the experiment again. Understand? So such example are there are so many such examples in our real life. Geometric experiment. Once you succeed, then you don't have to do it again. Okay? And that the experiment is done over and over again until a success occurs. All right? Like the first example, hey, blind date. All right? Once you succeed, Once you like each other, then you don't have to attend any other blind date again. Okay. The total probability is 1. 1 to infinity. It is 1. Okay. X from X from 1 to infinity. Probability X equal X. Right? X equal X. It is let me define Q is equal to 1 minus P. So it is 1 minus P X to the X minus 1 and M times P. Oh, sorry. I have to generalize further before I prove it. Yep, here. To generalize further, one minus P, X minus 1 times P, X equal 1, 2, 3, all the way to infinity, all right? Or just Q X minus 1, P. Okay? And let me prove that for any value of P in 0 and 1, the total probability is 1. All right? Q X minus 1 P. So it is P 1 plus Q squared plus Q 3 times. Okay? That's a geometric series. And it is P 1 minus Q. The first term, 1 is the first term. Q raised to the power infinity, which is, it tends to 0. Okay, as the power goes to infinity. So it is P times 1 minus Q 1. But 1 minus Q because P is 1 minus Q. So Q is 1 minus P. Okay? Yeah. Sorry. Opposite. Because Q is 1 minus P, so 1 minus Q is P. So it is P over P, which is 1. So we prove that the total probability is 1. So what about the expectation? Expectation is calculate this way. X times X. X times the probability of X. So it is 1 times x minus 1 p. So it is p 1 2q 3q squared 4q power 3 all the way, okay, to infinity. And let us define it as where s equal to q. Oh no, sorry. To q 3q squared 4q power 3 all the way up. Let me call it 1. And if you times, if s times q, then it equal to and that let us denote it as 2. So 1 minus 2 yields 1 minus q times s 1 plus q plus q squared. We don't like the coefficient. Now the coefficient is kicked out. We don't like the coefficient. This is called coefficient. We don't like the coefficient, and then we have to find some way to kick them out. Now they were kicked out. They were okay. Now the formula has no coefficient, and it is equal to 1 minus q under 1. Okay. So as equal to q 1 minus q times 1 over q. All right. Yep. So oh, 1 minus q. Yep. So expectation of x is equal to p times s, and it is equal to p times 1 minus q, 1 minus q. So it is 1 over p. It's going to appear in your final exam. Here. Any question? Yep. What part? Where? What? Where? This one? This one? Here? Oh. The term in the parenthesis is equal to this term. All right? Let me give you a formula. Hey, this is called a geometric series. Hey, A plus AR plus AR square plus AR n minus 1. Okay? So it is equal to the formula 1 minus the common ratio, okay, or R, and A is the first term, always the first term, times 1 minus R number of terms equal to n. Why? Because it is 0, 1, 2, all the way to n minus 1. Okay? So 1 minus q, so 1 minus q squared, q to the power 3, all the way, it is 1 minus q. Okay? 1 minus q, the first term is 1. And 1 minus q, the number of terms is infinity. All right? Hey, q is something like, is a number with, is a fractional number. Okay? 0 point something times 0 point something times 0 point something, dot, 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 dot. Okay? With power infinity, then it goes to 0. Approaches 0. The limit is 0. So it is 1 minus q. 1. Okay? It is a famous formula for q between 0 and 1. All right? Any question? Yeah. So here. Um, let me give you an interpretation of why how to understand the formula. Okay? Suppose that okay? To understand why expectation of x is 1 over p. All right? Now suppose that okay, there are 4 black balls and 1 red balls in a bag. Then a red ball comes out, were selected, appear once, will be selected expect to be selected once in every 5 draw on average. All right, on average. So a red ball is expected to be selected once every 5 draw because there are 5 balls. 4 of them are black and one of them is red. Okay, so a red ball is expected to be selected once in every 5 draws. Understand? So on average, on average. So here, why 5? 5 is 1/1 over 5. Okay. If 9 black balls then there are more black balls than 1 red ball in the bag, right? So we need more draw to get one. On average, we need then expectation of x is 10, and 10 is 1/10. 1/1/10. Okay, which is also 1/p. If p is smaller, then you need, on average, you need more experiment to get one success. Okay, the success is can be expect to be occur much later. It's if p is much smaller. All right. You need more experiment to make one success. If you are a handsome guy, a rich guy, you got a rich parent, and you have you are driving a handsome car, right? Then P, the probability you will make a successful blind date, the probability is very big, right? Then how many times you need to succeed in a blind date? Maybe just 1 or 2 because you are in good condition, right? You are very likely to be you know to be to succeed in the blind date. So the expected number of blind dates uh, is 1 over, for example. For example, if Johnny, handsome, tall, and rich, and he has a handsome car, a beautiful house, then a probability is very likely if um, we will get this right with very big probability. So how many times does he need to attend the blind date? It is 1/10. 2 blind dates to make a success, and the final case, this right? But if Johnny is not handsome, he looks, looks brutal, right? Clumsy, right? And he's poor and short and fat, right? Then the probability he will make a successful blind date is 0.01. So how many times does he need to make a successful blind date to find and find is the right expectation is 1 over p. It needs 100 blind dates to find this right. Understand? So that's the interpretation of the formula, 1 over p. Right? The more likely to success you will make a success, the less expected number of trial you need to take to make one success. Understand? Any question? Roll call time. You got only 6 seconds. Don't pass it to the absent student. Hey, 1. Wrong class. Hey. Is it today? Delete it. Again. This one. 6 seconds.
他没点到哎。
等一下，我会帮你处理啊。
好啦。
等一下，我要先上传，要不然我会忘记。怎么会这么久呢？没有，只有一次，后面那一次就好了。
没有点到。没有。3次啊，9号不用。10块。
对，什么名字？
还有消体汗，
前面、后面、中间。
应该蛮后面的。那我上个礼拜有请假。
哎，没有，我没有销价的。
哦，你没有销价。
因为现在也没有扣考了，哎，我就加分性质的，哎。
那怎么中间？
什么名字？
陈仲威。第二个。
哪里？没有啊。
Sorry about the exam. I think
Yeah.
I get the one the form like that.
Yeah.
So do I need to give
Because you use my formula.
Oh yeah.
Okay. Okay, I will fix it.
Okay.
Do
I need to give this to
I will go over the whole class.
Okay, okay.
Okay, not now. Yep.
I just want to ask something.
Yep.
Is there any possible ways there for me to do something to get a better margin?
To make it up for the midterm.
Yeah.
How many points?
I got 48.3. So can I do something for?
You already done a lot for me. I will give you some extra bonus.
Like the passing score is 60, right? Can I do something for
I will tell you if you need more. All right.